talking about Chapter 6, and Chapter 6 is all about trying to explain the behavior of electrons. And we envision electrons as orbiting the nucleus, like the planets orbit the sun, but that's not what's going on. If you've watched the video from the NOVA special that I had posted, classical physics does not explain very small particles like electrons. That's where we use quantum physics, also called quantum mechanics. Niels Bohr was one of the scientists that was trying to explain the behavior of electrons. And if you'll recall from that video, Bohr came up with the theory that there were these allowed orbits, that there was no in-between on the orbits. And so an electron would be either in orbit 1 and orbit 2, but nowhere in between, and you can't see it anywhere in between. So Bohr studied hydrogen. Now, if we're studying electrons, why would hydrogen be a good element to study? So think about that. Come up with an idea. Maybe you might say because it was abundant. But how many electrons does hydrogen have? It only has one electron. So Bohr studied hydrogen because it was the simplest system to study. So what I have here is a hydrogen lamp. So the lamp, the bulb has trapped hydrogen gas. When the electron, there's a lot of hydrogen atoms, and each of those atoms has an electron orbiting the nucleus. When that electron gets excited, electrons get excited, it jumps up to a higher orbital, okay? It absorbs the energy. Now, how do you excite an electron? Well, you can excite it with electricity. You can excite it with heat. What I'm going to do is use electricity. When that electron gets excited, it jumps up to a higher orbital. That's a high energy state. It doesn't want to hang on to that energy. So it emits that energy in the form of light and falls back down to its ground state where that electron is orbiting in just the first orbital. And this is a constant process, but look, this is what a hydrogen lamp, this is the color of a hydrogen lamp. And so what Bohr did, and y'all are gonna see it as well, is he looked at hydrogen through a spectroscope. And if you were here, I have a whole bunch of little plastic spectroscopes that you guys would look through. If you look at the sun through a spectroscope, you see a rainbow of colors. Roy G. Biv, y'all have heard of that, right? The sun emits all wavelengths of light. But if you look at hydrogen through a spectroscope or any element, it produces a very distinct pattern called a line spectrum. There's some line spectrums in your book on page 243. And the line spectrum for hydrogen is there, y'all. It's known. If you looked at this through hydrogen, you see 4 distinct lines at certain wavelengths. That's always hydrogen. A line spectrum is a fingerprint for an element. What can we say about all of our fingerprints? They're unique and they identify us. That's what a line spectrum does for an element. Have you ever wondered how scientists look at stars and will tell you what elements are burning in that star, or look at planets? We've never been to the stars or been to the planets. They compare the light given off by those stars and planets to elements that we know. They look at their line spectrum and they match them up to identify those. Okay, and so this is hydrogen. It's a really pretty lamp. I'm going to show you a few others. This is Mercury. And so y'all, pretty kind of blue color. We've all heard the term neon lights, right? That's a generic term. I do not have one that has neon in it. True neon lights have an orange glow to it. But neon light, like I said, it's a generic term. Not all bright lights in Las Vegas are neon. There's different elements in them that make those colors. And that one's helium. Okay, and so each of these, looking through a spectroscope, would have a different line spectrum.
Okay, so Another way that we can identify different metals is by their flame test. As we saw with the hydrogen lamp, different elements give off different line spectrums of visible wavelengths of light whenever the electrons are excited. And in this case, what we're going to do is we're going to take different metals and we're going to burn them in a ethanol solution, and we'll see that they produce different colors. This is essentially how fireworks are made, or at least the way they used to always be made. So I'm going to go through and I'm going to add a sample of each one of these. I'm going to start out with, this is cupric chloride, so that would have copper in it. I'll put that into this one. The next one, I got to grab my paper towel so I can wipe this off, is lithium chloride, which is wet because it is hygroscopic. It draws in moisture from the air. Somebody didn't put the lid on that very well. We'll need to rinse that off. We have barium chloride. You see, the chloride is going to be the same in each one of them. Now, each element has its own line spectrum, but the chloride is not going to interfere because each of these is a chloride salt. Calcium nitrate here, which is also hygroscopic, so it's quite moist. Wow. Humidity in Mississippi. Strontium. And we'll have these labeled in the video also. And this next one. And then the very last one here is a potassium chloride. Potassium chloride is a salt substitute, as you may be aware. Takes the place of sodium chloride. Put that in there. And then the one on the very end is an unknown. Now, I'm not going to tell you what's in the unknown, but you get to guess that. Make a good educated, good old college try. So to each one of these, I'm going to add about 10, maybe 15 milliliters of ethanol. This is pure ethanol. And I'm going to add it into each one. The first evaporating dish does not have any salt in it. It doesn't have a metal salt. So that's kind of our control, so we can see what ethanol normally would look like. So we're going to pour some in there. We'll put it in here with the copper chloride. And then here with the lithium chloride. Oops, a little too much in that one. Here with the barium chloride. Here with the calcium nitrate. We couldn't find calcium chloride, but it works the same. Here with the strontium chloride. Got enough of that one. And with the potassium chloride, and then our unknown on the very end. Now, just for good measure, I'm going to take each one and give it a good little swirl. Even my control, which was just ethanol on that first one. All right, these are mixing up nicely. All of these are water soluble, and ethanol, as you know, is also water soluble. And so since ethanol is water soluble, that means that things that typically would dissolve in water would also dissolve in ethanol. Likes dissolve likes, is what they always say. Give it a little stir on that one, and then last one down here, and then our very last one, our unknown, which we're going to test last there and give us a comparison. So I'm going to take a match, and I'm going to light these. Yes, you take the lights off, please. The first one, this is the pure ethanol. You can see it has a slight blue hue to it. That is characteristic of ethanol. When it burns, you know, didn't think about putting these out each time. The second one has copper in it. We can see a different color there. I'm going to go through and stir them in a moment. We have lithium, barium, glass stirring rod, please. Strontium. Oh, matches are burning my fingers out. Potassium, and then our unknown on the very end. I think there's a stirring rod in here. So we'll try to prevent a little bit of cross-contamination by just wiping off and cleaning them. So ethanol, we stir it up. You'll see. That's it. And I got to put my flame out. This is the one with copper. It's So you can see what happens there with copper for sure. A very beautiful green color there. The next one is lithium. We can see that when we agitate the lithium and we get it stirred up into the solution, we have a different color there. Next one is barium. You can see the barium is not as pronounced, but you can see it at the base of the flame mostly. It's a little hot over here. Now we have calcium. And then once again, it's mostly at the base of the flame where you'll see that. Somewhat of an orange color. Next is strontium, one of my favorites. And then the last one here is potassium, which should be yellow, which isn't very evident. Oops. Put the fire out. And then our unknown, we're going to try to see which of these colors does our unknown look the most like. You should be able to identify it from the colors there. All right. Now I have to put all these out. Did not think that through.
I went and got so much glasses. We have 3 big ones.
Whoops.
It's a pretty one.
There we go. And another way that we can do a flame test to show the metals is actually inserting a wooden splint into a solution containing these. And this first one, and then putting it into the Bunsen burner. The first one I have here is potassium. I didn't see that one very good from the alcohol. And when it starts burning, there you see the yellow
And
sparks
sticks
and the
on fire.
lilac colors.
Just
Am I
put
not supposed to
the-
burn the stick? Oh, well, it would never come on. I always burnt the sticks before. What's this one? I can't read it.
Copper.
Copper. All right, is that good?
Mhm.
Here we have
Barium.
barium. Wow, I can't see what's written on these. Getting old. Lithium, I think.
Mm-hmm.
Okay. I can't get the stick out.
Oh, they are down in there.
Beautiful color there. And then the last one we have here is strontium.